how exactly the system of a Docker works. Okay, right now after some time we will be doing installation of Docker and will be running. So whenever you are running Docker, what happens is you will be running a Docker engine on the back end, and you will be running some commands, which is nothing but the Docker client through which you will be do some task, whatever you're doing, right? So practically the first thing what you will be doing is, let me show you. So first thing, you need to store the images everywhere, right? So there will be a registry where you will be storing, or to begin with, the open source Docker system itself has lots of images available. So you don't have to create any image from the scratch. So Docker itself has lots of images available for free so that you can start downloading and use it. So whenever you want to work, the first thing is what image that you want to work. Like I said, if you want to work on a Red Hat, then you will download the Red Hat image. If you want to work on CentOS, then you will download the CentOS image first, because for a container, that is the base thing, right? So the first thing you will do is download the specific image that is required for your container to put and start working. And then as soon as you download, you will be getting the specific bootfs or the base image in your machine or on that Docker engine where you are running everything. So internally, Docker engine will try to take the specific image and download it from the Docker registry in the internet to the specific machine on which you are running. And once it is done, based on this image, you can create as many containers as you want. Now, if you understand, a base image is one file. That doesn't mean that you will take it and physically put it into a container. Now everything is virtual. So if I want to create one container, I can use this image to create one container. And the same time, if I want, I can create another container with the same image. So it is just going to take a copy of this image and keep on putting everywhere. So it's not like something physically you use one image for one container. Okay. So it's just a virtual place wherein when you create a container, you need a image. So that image has to be in your Docker engine. So for the first time when it is not there, you will always download it from the Docker registry, put into your local machine or the Docker engine, and from there you will create containers. So now, say if I download or if I need my Red Hat image, first thing I will download, and now I can create how many ever containers I want, wherein in each of the container can be based on the Red Hat image. So like this, we can create container. Now, once I have created a container, I can do some change. And once I have done some change, what we can do is we can create our own image based on that. Now, here, when I said this would be a base Red Hat image and it doesn't have anything. Say, for example, I created one container based on this Red Hat image, and then I added some files on top of that. Now, after that, I can create my own image on top of that. So that means from this container, I can create my own image. Now, this image will also be a Red Hat image, but the difference is the first one will be the scratch one from the Docker which we got, and the second one is it is the scratch plus some of our files what we have. Okay, so like that, what we can do is we can keep continuing to use the scratch image what the Docker gives, or we can create our own image from the containers. Okay, and once again, if you want this to be used by another people or someone else in your organization, then you can store back this image itself into the registry, so that at any point of time, if someone wants, they can choose whether they want to use this base image or this image of yours which has some specific software or some files already installed in it. Okay, so now the other thing what we can do is the containers whatever that we have created, it is not that it will always be running. So if you create a container once, you can stop it at any point of time and you can restart it at any point of time so that you don't have to keep the process of this container running always. Whenever you don't need this container, you can just stop it. So that is how you can handle the containers by starting, stopping, or restarting. And finally, as I said, either you can create a container based on an image or your own image. If not, you can write something called as Docker file. Through this concept, we can create our own image also. Even that is possible. So this is how what a Docker system would be working from an overview. So for the next couple of classes, what we are going to see, we are going to see everything one by one on how do you download the image, how do you create a container, how do you start and stop, how do you create a new image using Docker file, okay, and then how do you download everything. So this is what we will be seeing it. Okay, now coming to the actual part, how do you install Docker? Now, when you want to install Docker, Docker comes in, completely a open source. Now, when you're saying open source, there are two ways of installing it. Now, one is the native package way. Native package means in Windows, if you see, we call it as a exe or an installer, right? You will be having generally a exe which you double click and it will just take you through certain steps, or on the back end it will just install. Now, if it is on a Linux or a Unix operating system, then we don't have any such installers, but we have something called as package management or packagers, through which we will be actually installing any software or any services on a operating system. So now these packagers depend from operating system to operating system. For example, if it is a Red Hat, or if it is a okay, if it's a Red Hat, it'll be something called as RPM. So if it is CentOS, then you have something called as Yum. And if it is Ubuntu, you have something called as apt-get or apt-get. Like that, every operating system has a specific packager using which you can install something in it and uninstall or create a service. Now, that is one way of doing it. If not, the other way of doing it is there is a common script which is available using which you can install Docker. Now, if you go to the site of Docker, so in the Docker site, they have an installation specific to each operating system. Okay, so here. Now you can choose what is that operating system on which you are going to work, and you have to run the installation. Say for example, my machine that I'm having is CentOS. Now again, as I said, in CentOS, there are two ways of doing it. The first one is doing it with the packager, and the packager for CentOS is M. So you have steps here. If not, the simplest way of doing the next one is installing with script. So when you are doing installing with the script, okay, so all you have to do is run this command. Okay, now before you run the command, you should always make sure that you have all the softwares, whatever it is needed in your operating system, is up to date. Now, how do you do that? So that is when you just simply run this first yum update to verify that your machine's updates of all latest software is available, just in case. Okay, so what I'm going to do now is the second one of using the script, because regardless of what operating system you're using, this one will be working. Okay, so first thing, let me first connect to a machine. Okay, so okay, now I've connected to a machine. Let me check if I've already installed Docker. Okay, I've already installed Docker and this machine is not up. Let me check, is it running? Okay, let me create a new server. All right, let me uninstall and show you how it goes going to. Quickly, what I'm going to do now is I'm actually uninstalling a Docker on an existing machine. Let's not waste time. Okay, there are two packages installed for Docker, and all I have to do is uninstall. Okay, so pretty much I've uninstalled Docker. So now let me do the same things from beginning. Okay, so this is one of the machine and it is a CentOS machine that what I'm using. Okay, so if you see, I'm using a Red Hat, sorry, I'm using a CentOS 7 machine. Okay, now CentOS is actually an open source operating system which was based on the Red Hat itself. So pretty much whatever the way that you're working on Red Hat will be similar to CentOS, and CentOS is one of the most popular operating system which is being used everywhere, because in the DevOps world pretty much whatever that you're going to work is completely on a open source. Okay, so that is what we'll be using it. So now going to how do you install. So first thing is let me check with the updates which is available. So first I'm going to say yum update, and right now if you see it is up to date, but say in your machine when you're running this first, it might take some time because there might be some packages which is out of date. Okay, so you're going to update everything to your machine. So it's less like on your Windows, on the box here it will be asking you that there is a new software or there is a new patch that is available that you want to install, right? So that is what you're going to do the same things here also. So the first thing that you have to update the operating system with everything. Okay, now the second thing is I'm going to run the script, which is nothing but internally if you see it is using a command called curl, through which it will be contacting the Docker site, and from the Docker it is going to run a script which is available in it. Okay, so okay, if you've already installed the script can run. Okay, since I've already installed it saying, but anyway. So now, once this is done, how do you verify whether Docker is available? So if you run this command called which Docker, it will tell you whether Docker is installed, and if it is installed, what is the path. So right now, if you see, it says that Docker is installed and it is available in this path. Okay, so now we have installed Docker. That was quite simple. But it's not sufficient for us to start because it is only installed. That means whatever files that is required for Docker, it is available in this path called /bin, and it is been showing us from there. But what we need is we need to run the service. Service is nothing but the Docker engine, whatever I was telling, right? You need to keep on running that. So in order to run, what you need to do is you need to use a command called service docker start, or pretty much depending on the operating system, you might be using system control. Okay, so okay, now if you see, it is saying that for this operating system, it is going to use system control. So few operating systems use this. So based on your operating system, either you can run system control, Docker start, or service start. So now what I've done is we have started the Docker service, which is at the back end. Now, if I close this machine or if I restart this machine, every time you have to run this service. It is because you have installed Docker. That doesn't mean that it is running. So in order to run it, you need to run it as a service. So that is what we are doing it here. So right now, what it has done, the Docker is installed and the service is running. So once it is done, the next thing, how do you ensure whether it is running? There are a couple of ways that you can do. You can just check for the process of Docker which is running. Okay, so right now if you see, there is one process called docker d, which is nothing but the docker daemon which is running. Okay, so this ensures that I have docker installed and running, and also you can run a command called docker info. Now this will give you a complete details about what docker that you're using and what and all are the contents that it is requiring. Okay, so pretty much once you have done this much, it's easy for us to proceed with next steps. So what we have done, we have installed Docker and we have started the service. Okay, and we are all set to start working. So once this much is done, the next thing is we have to start working. Now, when you have to start working, the very first thing I need to know is that I need the image that is available, right? So in Docker, it's all about having an image and working on containers because every other thing is internal. So from the user perspective, if you see, the only two things what you will be doing is you will be creating a container and you will be working inside the container, or you will be working on a image creation. So that's the only two things that you will be doing. So now in order to bring a container first, okay, so we need an image. For the very first time, when you're trying to create a container, if the required image is not available, automatically the Docker engine will pull from the Docker registry of the Docker which is available on the internet, and it'll do it. So for the first time when you are creating a container of an image, it will take some time to download the image automatically. If you already have it, from the further runs, it will run it very fast. Okay, so going forward, it's all about creating containers. So how do you create a container? That is the very first thing that we are going to see. Now, going forward, for working on Docker, what is that we are going to do is we are going to use a command called Docker. Now, this command is nothing but the client, which internally it will be talking to the Docker engine which we have installed on this machine and through which we will be contacting it. Okay, so the first command in Docker that you need to understand is Docker run. And what is this option called run? So this is the option or the command using which we will be able to create a new container. Understand? A new container. So when I want a new container, what is that I need? The first thing I need is the image, right? So you need to specify what is the image that you need for a container. And now, other than that, what and all are the things that you need? So other than that, we need to have one more detail about what will be the starting point of the container in which you can work. Now, what do you mean by starting point? So let me show you that also. So if I create a container, okay, So now say that when I create a container on your machine or in this machine, whatever I'm working, it will create a container. Now in that container, you will first have to say the very basic thing is what is the layer of the image. So you will say that whatever layer of image that you need, it will come here. Okay. Now, once it is done, you need to go inside this container and start working, because right now if you see, assume this is my machine on which I'm working. So what is this my machine? So this is AN Murga 1, which is nothing but a CentOS machine, right? So this is a CentOS machine, and this is the name of my machine, and operating system that I'm using is CentOS. Now inside that, I have created one container, okay? And if you see, this is a container, okay? And inside this container, whatever image that you put, based on that, if you go inside the container, you will be working as if it is a new machine. Now say this is the container of Ubuntu, okay? Now so now, whenever from this machine, if I go inside this container, I will be working on a Ubuntu operating system. So until I am working inside this container, I will be working on Ubuntu. That means any commands, anything I work, it will be on a Ubuntu operating system. Okay, so it is like you are working on a separate machine on which you have installed Ubuntu, but it is not a separate machine. On the same machine on which you are working, you are just inside a container or a process. So now, when you are going inside a container, you need a process through which you can run everything, because in Unix or Linux, everything is process, which means you log into a machine, that is also a process. You install something, it is also a process. You are running something, it is also a process. Okay, whatever you do in Linux, everything will be treated as a process in the backend, and that is how the operating system or the kernel that is present in the operating system will be understanding, and it will be handling everything that you're doing. So in the same way, now when you create a container and put an image inside it, you need to go inside the container, right? So when you are going inside the container, you need a specific shell, which is nothing but a process through which you can work. Because every time when you log into a machine, there are a couple of things that happens. Okay, now for those who doesn't know, let me give you an overview of that. So what happens when you log into a machine? Okay, can anyone else tell me? Akash, Ravi, what happens when you log into a machine? Any idea? No? Okay. So what happens when you're logging to a machine? So for an example, if you see I connected to this machine, or if you want, you can connect to any other machine. So whenever you connect to a machine, what happens is, the first thing is you will be going to a directory inside that machine. Just like here, let me open one more instance. Okay, so now I'm connecting to the same machine. So if you see, I went into some directory. Every time I go to this machine, okay, every time I connect to this machine, I go to the same directory. Now what is this directory? This directory is called as home directory. So what is a home directory is, in this machine, this is the directory where you have permissions to create files and store files. It is because, unlike Windows, where in Windows only one user can log in and access that machine at a given point of time, but in Linux, many users can connect. That is the difference between Windows and Unix or Linux. Now, in that case, what is the directory on which you should be working on the machine? Because now, when I go to my Windows, now I can create as many drives as I want, I can work. right? Because usually only one user will be accessing it. But on a Unix or a Linux machine, how can you allow many people to work? So in order to allow many people to work, each one of them should have a specific directory so that you can store files and you can do something for your need. So in that way, whenever a user or whenever a system administrator is creating an account for a user, he will be creating a home directory, which is nothing but a specific directory in the machine where you will have all the permissions. So by default, whenever you are connecting to that machine, you will always go to this directory. So not only in Unix, even in Windows, we have this concept. So if I say command prompt, you see, I always go to this directory. Now, what is this directory? This is the default home directory for whatever user I have connected in my laptop. This is the one. So not only this, no matter how many times I connect, it will always be there. Now, what is this? This is a Windows command prompt. In the same way, in Unix also, you will have a home directory that will be created by the system administrator for every user account. Okay, now this is the directory where you go first, and this is where we will be putting all the files that I need and I'll be working. Now, other than this, the next thing what you need to have is something called as a shell environment. Now, what is a shell environment is, as I said, everything in the Unix or Linux is process. So in fact, if you see, if I run a command pwd, it is running a process internally. If I connect, it will be running a process like this. Everything that you enter here will be running on a process. And psef is a command using which you can actually get all the process that is running. Okay. Now, in order to run a process, okay, you need an environment through which you will be communicating to the operating system, and that environment is called as shell. So shell is nothing but an environment or a interface between the operating system and user. So by using some tool, for example, you can use a tool like putty to connect to a machine, or I am using a tool called xshell. Okay, now what does this do? It is helping you to connect to the machine, but it is not directly doing it, but it is directly creating an environment for you. Okay, so if you see here, I am able to run something. That is because it is helping me to create a shell environment. Okay, this is a shell which allows me to enter any command, wherein for every command that I enter, internally a process will be created. So that is what we actually need. And now there are lots of different shells that is available in the operating system through which you can use. But right now, if you see, the most widely used shell is bash. So you have shell like bash shell, C shell, which was used long time back, but right now everyone use this as an environment. Okay. Now this is the environment that we need. In the same way, along with your home directory, the shell environment will also be specified. So whenever a user connects to a machine, okay, there are two things that happens. First things is it will go to your home directory, and then based on your user account, there will be a specific shell that will be set by the administrator. So these two things will set. And additionally, there is one more thing called as startup script. Okay, so what is the startup script? Now, whenever you are having an environment, so right now, if you see, whenever I connected to this machine, I got my home directory. That is where I am going. Second thing is I got one shell environment from where I am running some command and specific to what shell I am using, that has been specified. And the third thing is, if you see, we are able to run certain commands, right? So how does it know? That is when there will be a script called login script or startup script where you will be setting certain default environments which is needed for you. Okay, so that is why you are able to run everything here. So now this login script again will be specified by the operator or the system administrator, wherein what is the environment that you have to set. So if you see, you have so much of environments that has been set for you, and depending on your shell, this will be varying. And how can you see this? Oh no. Okay, so in your home directory, okay, so there are certain files hidden. So if you see, you will be having a file called bash rc. So this is the shell script using which whenever you log into a machine, your shell environment will be created and all the specific environment which is needed by that will be set up by running it internally. So these are the two things that happens. Okay. Now, why was I saying this? I was saying this because here, if you are creating a container, this container is going to act as a new operating system for you. So, in order to go inside the container, you need a entry path. What is that entry path? That entry path is nothing but the shell. Okay. So now where will you run this? Because we need a new shell inside this container so that you can interact. Because when you log into a container or when you go inside a container, you are actually going inside a new operating system called Ubuntu. But unless and until you don't create a shell, you will not have the interface. So as I said, shell is the one which will have a interface so that you can run the command. And that is when by default, whenever you are logging to any machine, the two things will happen. That is, home directory will be created and you will go there and you will have the shell environment, and that is the reason why we are able to run this command. But pretty much in a container, if you see, we are not creating anything, we are just creating one operating system. So it is quite important for us to tell what is the environment or what is the shell that we have to use. Okay, so those two things will happen together. And coming back to this, here, whenever you are running this command called docker run, you have to specify minimum of two things. So what are the two things that is needed? The first thing for the container is what is the image that you're going to use? That is the first. And the second thing is what is the entry point or what is the environment from where you want to start interacting with this operating system inside the container. Okay, so that is the two options that you're going to specify. So be very clear. Container is nothing but an empty space on which you are trying to put a image with a specific operating system. But unless and until you do not have a entry point or a interactor or an interface, you cannot do anything inside it. So the only way to get an interface is you need to have a shell environment. Okay, so the next thing what you will do is to create that shell environment, you will specify what is the environment on which you will be running. So now this is the environment through which you will be creating all this layer, whatever I said. So the layers, whatever that you want to do, will be on top of this like this. So without this shell environment, you cannot connect and do anything. Okay. So now coming back to the requirement. Now this is the command called docker run, using which you will be creating a new container. So for that, the first option what you have to say is the name of the image which you are going to use, and then followed by what is the environment or the shell which you want to run first. That means now whenever you run this command called docker run, first thing what it will do is it will create a container, And inside that container, it will put the base image as Ubuntu. And after that, here it will allow you to go inside, because the docker run command does two things. It will create a container and it will allow you to go inside it. So it does both the things. So when you are going inside the container, you need an environment or a interface between your operating system and you. So for that, you will specify that you are going to use this bash script or the bash shell. And that is when here, this will be the bash shell. Okay, so now you will be logged inside the container and you will be having Ubuntu inside it, and using this bash, you can type commands as if you are working on a new operating system. Okay, so that is why you need to specify this two options. Now, along with that, if you see, you will have to pass two other options called -i and -t. So why do we need this options called -i and -t? So -i stands for keep the container open for the standard input. That means you need to interact with the container, right? So it is not like you need the container to be running on the backend, but you want to type some command. So if you want to type some command, it is not directly on the container. First, you are going to run some command here, which is going to directly get inside here, right? So whatever input that you're giving, that the container should be able to take. So that is why you will say this -i. So without this -i, you cannot type any command which the container will take. Okay, so you are creating the input to the container. So use the -i. The next one is -t. So -t stands for a terminal. Terminal in the sense, if you see here, whenever I connect to that machine, it opened a new session. This is nothing but a terminal. Okay, so whatever tool that you're using like Putty, Excel or anything else, every time you connect to a machine, it will create a separate terminal through which it can handle whatever you are doing, as if a different user is connecting. Right now, it is the same user, I am connecting it for multiple times, but assume that if you are connecting, then it will create one more terminal. So in that way, now within the same Docker, what I'm connecting, it needs a terminal so that the operating system will understand that it is a new operating system and it is working. Okay, it's only for the operating system to understand that I am running something. Because if you don't have this terminal, you cannot create the container at all, which means you cannot get into the container. It will be running. So for you to connect, it is like a, I know, how can I say to keep it in simple word? Now, say you are going to some place, right? You need someone to help you to travel. So you can think that this is the one which facilitates the traveling. Okay, like an agency. Now, through that agency, you might be booking some ticket for your public transport, like bus or flight. So that specific thing here is your container. So now, how you're going to do? That is, to work on the container, you need the shell, but to connect to this container, you need a terminal. So and that terminal is what you are specifying using this -t. Okay, so we will see a couple of other options also, wherein many times you want to just run the container and you don't want to connect. So two things. Now, whenever you are creating a container, if we have to work inside the container, then I have to give both this option called -t and -i, wherein -t helps me to see the container which is running. Okay, and -i will help me to type some command on the container. To keep it in very simple words, -t means to see the container, -i means to give some commands to it so that you can run. Okay, and then what image that you're going to use, and then what is the shell or the entry point from which you are going to run everything. Okay, so this is what we are going to do. So let us first run our first command so that we create a container. Okay, so now here let me run docker run. Okay, hyphen I and T. So either you can give separately or give it together. It's all one and the same. And then you will specify the image name. Okay, and then you will specify the script that you're going to use. Okay, so here if you see, I'm giving a path called bin bash, but I'm giving a double slash because if you see, actually every operating system will begin with root. So in the same way, so the file is available only in the bin and it is starting from the root, but here I am giving a double slash. That is because when you are connecting inside a container, the slash will be negated. Okay, so in case if it doesn't work on some of the image, then you always have to give a double slash in the beginning. So that is the only reason why I'm giving. When certain operating systems on which you are working, it might negate the slash because it has a separate meaning. So that is why I'm giving a double slash, which the second one will negate the first one and you will get the actual meaning as slash bin slash bash. Okay, so once you have done, okay, so if you run this, so if you look closely, it is saying that the image is not available because the system on which we are working is empty. Empty in the sense the Docker engine doesn't have anything. Okay. And what it does first is it is trying to download the Ubuntu image locally to your Docker engine and then it is going to run. So what it has now, if you look closely, it has downloaded the image. Okay, and next, what is that it has done? If you look closely at this step, now, what does this mean here? You see, you have connected as root on this machine called ANMurga1. But as soon as you completed running this command, you are not inside this machine. Then what is the difference? That means you are inside some number. So what exactly is this? Let me type the host name here. So if you see, hostname is the command which tells you what is the name of your machine, right? Now let me run the hostname here. What is it saying? It is saying that the name of the machine is ANMurga1, correct? Now, whereas now, if I run the hostname, it is giving me some other number. So that means you are not inside your machine, but you are inside the container. So this is the name of the container. Okay, so whatever container that we created now here, so here we have created a container. Okay, so from my CentOS machine of ANMurga1, I ran this command called docker run. So what it did is it used the Ubuntu image and it created a container. And since this container is going to act as a separate machine now, the name of this machine is whatever that value that it generates by itself. So there are ways where we can give a specific name of the container also. But to the beginning, let us stick to the standard. What is it trying to do? So right now, if you see, I am not inside my machine, but I am inside a container. And in that container, I am going to have Ubuntu. So here, if you, so you have this file called OS release. So this is the one which will specify what is the operating system. Okay. Now, let me do a cat of this. Okay, so look what is it saying. It is saying that it is a Ubuntu machine, whereas this is the actual machine, right? So if I say, what is it saying? It says it's a Red Hat. Sorry, it's a CentOS. Now, here, it is saying Ubuntu. That is because you are not actually working on your machine now. You are working inside the container, and in that container, you have this image of Ubuntu. So now you are actually inside this container, and in this container, you have Ubuntu. So it is a Ubuntu machine on which you are currently working. So now, if you see, we are not inside the machine on our host. We are inside the container which is having Ubuntu. So now simply you got a Ubuntu machine. It's as simple as that. Now anything that you want to do, you will be doing it inside this container and not on your operating system. Okay, so here if you see, you have a specific directory, you have specific file, and which is the user that you have connected. It is the same user as which you ran the container. So for every machine, you will need a user account to be created, right? But the difference here is it is not a complete operating system. All right, it is just a image on top of your existing machine. So whatever user through which you are running the docker run command, the same user will be created inside this machine and it is running. So now we are actually inside the container which is containing the Ubuntu image, and now you have a Ubuntu image. So whatever that you want to do, you can pretty much do inside it, and this is your Ubuntu image, or you have a Ubuntu machine for your purpose, whatever you want. So like this, I can create one more container wherein I can give Red Hat or give CentOS, and without creating a separate machine, I can create a own container. Okay, now you can work on this as long as you want. Now if you have completed your work on this machine and you want to come out of this container, then simply say exit. So when you say exit, watch closely, you are coming out of the container. Now here if you say hostname again, you will be coming back to the original operating system. That means whenever you say exit, you will be coming out. And again, as I said, what is the operating system here? It is the CentOS. So like this, whenever you need a different machine to work, rather than creating a machine on the instance, all you have to do is create a container and then go inside it. For that, you need a specific image from where you will try to start working. Okay, and that will be done using the docker run command. Getting it? Any questions or doubts before we proceed further?
Adam, if you want to run the container again, what we need to do? We need to run the same command.
I will come to it. I'm just going one by one.
Okay. Okay.
So I'll show you all those things. But now, before I jump onto it, I'm just trying to give you all the essentials. So is it clear now what is a container? How is that I'm creating all those things so that let's get more deep into the practicals.
Yes.
Others? Akash, Himanshu, Ankit, Mohammed.
Yeah, it is clear, Adam.
Okay,
Yes.
good. Now, before we get into now, the question that you will always have is, what is the name of the image that I have to use? Because I just gave Ubuntu, right? So is it a standard? How can I know what is the name of the image is the question that you will get. Now, for that, what you need to do is, there is a command called Docker images through which you can try to search what and all are the images that is available. Okay, so the first thing, if you say Docker images, if you see, Docker images will let you know on your current Docker engine what and all are the images available. So right now, if you see, we just downloaded only one image called Ubuntu. correct? Now that is why we got only Ubuntu in my current machine or the Docker engine. Now, how do I know what and all are the other images that is available? Now, if you see, we will be having many images on the Docker registry, which is available in the open source. Now, to know that, either you can search for a specific string so that it will give you every list of names of images available. So for that, you can use the Docker search command. Now, if I say Docker search and Ubuntu simply, okay, now see what and all it will be giving you as an output. So here, if you see, it is giving a list of commands, sorry, list of options here. So what is this? These are all the name of the images which is available for us to use. Whereas the very first one is what we used. And if you see the description, this is the Debian based operating systems image which Docker itself is giving us from the scratch, which is the base image. But along with that, we also have so many other images that is available. Now, what is the difference between this and this? Now, the difference here is this is the actual image which is being given by the Docker, but on top of that, you can create your own image. And these all are that specific image wherein it is going to contain this Ubuntu, plus on top of that, it is going to contain some other application or software also. Now, that is why it is quite easy and so popular that if you want to install something, you don't have to install it always. So now, say, assume I create a Docker here. Okay, I'm just giving an example. Now I created a container. On this container, I put some base image, and now inside this, say I install some software like Jenkins. Okay, now if you install Jenkins inside it, you can use Jenkins as long as you want. But now, if some other user wants to install Jenkins, he doesn't have to install it from the scratch. So what you can do is, from this container, you can create one image. Okay, now when you create that image, you can give a name of that image called Ubuntu Jenkins, something wherein you can understand. So now, if any user uses that image which you created, now what and all he will get? So whenever he creates a container with that image, he will get the base Ubuntu plus a Jenkins already installed in it. Okay, now that is why people are actually focusing completely into Docker, and over the next couple of years, the usage is going to be completely high because you don't have to install many things. You can have everything pre-installed. And as I said, it's easy for sharing the environment. Now, no matter how many times you want to duplicate the task, it's quite easy. So with just one command, you can get the things done and you don't have to do the same thing now for many of the other tools or applications. If you want to install everything, one way is you can manually install everything and use. If not, simply all you have to do is get a Docker image which has a specific software, whatever you need installed. So that's as simple. Now here, instead of searching for Ubuntu, if I say Jenkins, you see it is giving me so many operating system and it is giving me so many image. So what is this going to contain? Suppose if I use this image, now this image is going to contain some specific operating system as the base, and top of that Jenkins pre-installed, so that now you don't have to install Jenkins separately. You can have one machine, and inside that machine the Jenkins is also installed. Like that, you have every container for Docker or image for Docker which has some software pre-installed. So that is the best thing because you don't have to waste time. So why I was saying all these things is you need to search for whatever image that you need, and based on that you can use, wherein you can use a specific base image or scratch image, wherein if you use these kind of things, this will be the official image which will not contain anything else. So either you can use the scratch image, or you can use the image which is pre-existing with some applications or software built on top of that. Okay, so you can use whatever image that you want. So Docker search and you can get it. Now, the next thing is, if you want to use something, now if you saw some time back when I ran the Docker run command, since the image was not available, it was trying to download it first, right? So suppose if you don't want to happen, that means you don't want the image to be downloaded when you create a container, because in the production, if you are trying to create a container, you don't want to waste time in downloading. Then you have to download it separately. So how can you download? So that you can do using a command called docker pull. Okay, so all you have to say is docker pull, and you will specify the name of the image, whatever that you want to download. So by this, it will first download separately. And so that next, when you do a Docker run, you can use this container so that rather than downloading it, it will use the existing one. Okay, so we will see about this Docker pull at the end on how do we create a registry and do all those things. For now, make sure that you can search for a Docker image using the Docker search command. Okay, fine. So we saw about creating a container and what images that we need we can download and use. Okay, so now let us get inside a little deeper. So as I was saying, now we can give a name to a container rather than just giving some random name which the Docker itself creates. Okay, so how do you see that? So now for that, the Docker run, we have an option called name, wherein you can name the container. Okay, so now going forward, you might have many containers on the same machine which you are running. So how do you know what is the container? For example, now one of the question that you guys asked me some time back is, how can I connect back to the same container that we have, right? Because we exited. Now, when I exited, that doesn't mean that container is not existing. The container is still running, or it is not running, but it is still present in my machine. But how do I go back to the container? I don't know what is the name of the container, right? So it is quite complicated to remember the name. So for that purpose, you can use a name for the container. And for that, you can use this option called -name. Okay, now let us run it once again. So I'm going to say Docker run and the name of the container. Okay, so let me say the date today. So I'll say August 2101. Okay, I'm just giving, this is the name of our container just for our easy understanding. And then followed by the other options -it, and what image you want to use, Ubuntu, and then I want the bash to be the first command or the shell to be available so that I can run all the command internally. Okay, so now if you see, it didn't download anything because the Ubuntu image is already available on our engine, so it directly created a container. Okay, so now the name of the container what we are using is August 2101 underscore container, so that now whenever I come out of it, we can still use specifically on this. Okay, and remember, whatever you are doing inside this container is only known to this container because this is acting as a separate operating system. So now let me show you simply one thing. Okay, now so there is a folder called TMP, or temporary folder, for every operating system. So let me create one file. Okay, I'm creating a file called August 2101 container. Okay, so I have created a file inside TMP, correct? And where is it present? it is present inside your container, because currently where am I? To cross check, you see I am inside my Ubuntu machine, and in that Ubuntu machine I am trying to create a file called tmp and a file here. This is available, correct? So once you have done, you can simply come out. Okay, now when you come out, you are back to your operating machine, I mean operating system of your host, that is CentOS, that is the machine in Muruga 01, correct? Now here, let me search for the same file. So you see, the file is not existing. That is because whenever you are doing something inside a container is specific to the container, because you created a file here in the temp, and now that is available specifically only inside the container. So here I created a file, right? And now this file is available only inside this container because this is acting as a separate operating system. So now like this, you can create containers with a specific name, and whatever that you do inside the container is known only to the container. Okay, now how do I go back to the same container which I have stopped it? Okay, now what you can do now is, since whenever you do a exit, what will happen is the container will be existing but it will be stopped, it will not be running anymore, so it will come out of it. So when it is coming out of it, what you need to do is, first thing we need to do is start the container. Remember, when can you start a container? You can start a container which is stopped. You cannot start a container from the beginning, right? There should be something existing, only then you can start. So docker run command creates a container, whereas if you have already a container but you have come out of it and you want to go back again to it, first thing what you need to do is you need to start the container. Okay, so to do that you will use the command called docker start. Okay, so now let me do the same thing. Here we have come out of this container, correct? And we are on our machine. So to go back to that, first you need to start the container. Okay, so first thing what we did is starting the container. So now when I started the container is running, but it is still running on the back end. Now we need to go to the container, right? Because again, Docker run command does two things. First, it creates a container and then it goes inside it. That is means it is going to do the command called start, and then it is going to do one more thing wherein using which you will go inside it. So for that, we will use the next command called docker attach. So docker attach will now help us to go inside to the container. So now if I say docker attach and August, this is the name of the container. Okay, so now you see, where am I pointing to? I am not on my host machine, but I am inside the container. So how do you know it? Okay, so you see that we are back to our container. Okay, and now if you go inside and see the specific file, you see you have it. Okay, so you're getting it? So at any point of time, you can go back to the container. So for that, first you need to start the container and then you need to attach. That is because whenever you do a exit, the Docker will stop the container. Okay, so that is when I meant in the first slide that you can start a container, stop and restart any point of time. So now anytime you want to go back to the same container, all you have to do is start and then attach it. Okay, Getting it? So now, how do I know what are the containers that is available? So to know the list of containers, all you can do is use a command called docker ps. Okay, so docker ps will give you the list of all containers that is available. So now if you say docker ps, it is not showing anything. That is because by default, Docker PS will show you only those containers which are running. So if you want to see all the existing containers on this machine, then you use a command, option called -a. So for that, if you use -a, so now you see it says that what is the ID of the container. Okay, so every container that Docker creates, it will have a specific ID using which it will be recognizing it as a separate operating system. So what is that ID? Okay, and what is the image that it is using? And then what is the entry command that you have given to run inside the container? And then what is the status of it? So right now, if you see, it says that it is exited 0 minute ago. And what is the actual name of the container? This one. August 21 container, right? But if you leave it, this is the earlier one. But you see there is some junk name that is being available. That is because Docker tries to create an own name. So that is why we are creating our name over here. Okay. So maybe if I can reduce it. Okay, let me run this. Okay. Now can you see? So if you see, this is completely exited. It is not running. That is the reason that the docker ps command is not showing you the output when you say just ps. So ps means it will show you only the running. So to do that, let me do it again here. So my goodness. Okay, I'm going to say docker start and August 2101 container, and I'm going to attach. So here it is connected and the container is running, right? So now if you run the same command, you see it shows only the container which is running, and the status is it is up and it is connected for the 14 seconds. Whereas if you want all the containers which you have in your machine, then you can just say docker ps-a. So remember, every time when you exit out of a container, you are going to stop the container. You are not deleting the container. You are just stopping the container. It is still present, but it is exited. Okay. So like this, you can create a container, stop a container, and at any point of time, if you want to delete a container, then simply use the docker rm command and the name of the container. Say for example, I don't need this container anymore. Okay, so simply I can say docker rm, and for that you can either give the container ID or you can give the name whatever that it is using. So you see that it has deleted. Suppose I don't want this, even I can do a docker rm. I can use the container ID or my name of the container. So there's no container that is available currently. You will say docker run, and for that you need to give the options of -i and -t. And here this first thing you will say is the image name, and then what is the entry script or entry command that you want to run. So if you want it to be bash, you can give bash or anything else that you want to do, but practically always stick to bin bash unless and until you don't really understand the environment. Okay, so now if at any point of time you want to give a name of a container so that you can remember it, then use a name and give the container name. Okay, this is what you're going to do. But as soon as if you want to come out of the container, just say exit and it will come out of the container. And once it comes out of the container would be stopped. So to have a look at all the containers that you have which is running, just say ps docker, or if you want to know all the containers which is available regardless of running or not running, then say ps-a. And to get back to a container, first we need to say docker start and the container name. And then once you have specified to start the container, next thing is you need to attach the container. Okay, so that you can go inside it. Getting it?